No, so that's how you set up that way. So I did like negative infinity without I always remember why. So that I was so confused because the intervals is out. That's like a you that way to define, you know.
All right, I'm putting the answers up on the board, and I have made a mistake on purpose. Let's see if you can figure out where the mistake is. Domain. Okay. I think I heard some people say where the mistake was. Where's the mistake? The y-intercept has an x equal to 0. 0 comma negative 5. Good. Okay, there's another mistake. Factored form. Pay attention. A lot of people don't know this one. You take the x-intercepts and you go x minus 1 and x minus 5. You do the opposite of these numbers. And then it's upside down. There has to be a negative. How many people did I catch on that one? You forgot the negative. Be honest. Who all forgot the negative? All right, thanks for being honest. Okay. It's so easy to forget that negative. All right, then standard form is you multiply this out. How many of you have already got your standard form all multiplied out? That's not that many people. Finish multiplying this out. Just take that, multiply it out. Even if you didn't have that, now you have it. Multiply that out. And vertex form came from the vertex, of course. And the vertex, which is right here, 3 comma 4, I go minus 3 and plus 4. Easy to forget the negative in the front, isn't it? Okay. That's vertex form. It's correct. Any questions so far? Now, some kid might say, I want to multiply this one out. You can do that. You get the same exact answer. Isn't that kind of weird? Yes. All right. I did say there was a mistake somewhere, and the range is definitely it. So tell me, what do you think the range is? Do you think I just need to change this to a bracket? There's something else wrong with the range. The range, here, I'll try to help you see what's wrong with it. It's supposed to be low to high. Is negative infinity pretty high? No. Lowest is negative infinity, so that should have been first. So this should be negative infinity first, comma 4, and, oh, it'd be so easy to forget the bracket. Negative infinity, comma 4 with a bracket. Man, math is really exact. But this is the real world. In the real world, if you want to put a satellite up and have it go around Mars and take really cool pictures of of Mars, they did that a long time ago. It cost over $1 billion, which is 1,000 million. $1,000 million, and all of a sudden it gets to Mars and immediately crashes. because somebody screwed up and they used meters instead of feet, or vice versa. I think actually they used feet instead of meters. So it got too close to the planet, and the planet's gravity sucked it in and it crashed. The point, you can make one little mistake and it can cost you $1 billion. That actually happened. There's probably one person personally who is responsible for that calculation and cost $1 billion plus all the scientific knowledge we would have got from that satellite. Okay. So, multiplying this whole thing out, I'm going to call on a random person. This right here should be multiplied out. Roll 4. Person 4. That's you. Katie?
Oh, okay.
What'd you get when you multiply that out?
I got negative x to 2,
Negative x squared. I agree. Keep going.
and then I got positive 6x,
All right. It would have been negative 6x, but the negative in front changed to positive 6x. Nice. Keep going.
and then minus 5.
And it would have been positive 5 for these two, but then that makes it negative 5. You're right. Good job. And what is standard form good for? Y-intercept. What's this good for? X-intercepts. What's this good for? Vertex. Okay, cool. Now this is the thing I think you're going to have the most trouble with. So I want everybody to try this one in the middle one. Doing too many of them will make you lose your mind, but if I have negative 3 comma 9 as my vertex right there, that'll help. Find the domain, the range, the increasing and the decreasing intervals. If I had to bet, that's going to get many, many problems marked wrong for you guys. So let's practice that. Okay. The dotted line down the middle tells the tale. That's halfway. So it's always increasing or decreasing on one side or the other. This is the increasing side. And so I say from this to this, it's increasing. You remember you're doing x values. So it's increasing from negative infinity until it hits negative 3. Okay? The decreasing then is from the negative 3 until, well, from here to here. Okay? In that zone. From negative 3 to infinity. The range from low to high, the lowest this goes, negative infinity. The highest this goes, 9. Bracket. I bet a lot of people forgot the bracket. And a lot of people would have said negative 3 instead of 9. The range goes with the y. Here's the easiest answer on the whole test. What's the domain of a parabola? It's always this. Always, always, always. Always, always, always. Because they go forever and they go like this. If you flip them upside down, they still go forever in both directions. Okay? So that's the easiest answer on the test. All right, move on. Put each into standard form. That's factored form. I already have the x-intercepts. So multiply that puppy out. Do the same for this. Do the same for this. All 3 of them. That's the number one thing I'm thinking you're going to have. Can you just pull on the door? Just pull on the door. Just grab the handle. Pull hard. Pull hard. There you go. I know you probably thought it was going to break. Okay. So, I hope you're multiplying this out first, and then you're going to distribute the negative. Pausing. Okay, here's how it should have gone. X squared minus 7x plus 3x. Some of you do that in your head together and make that negative 4x. That's cool. Minus 21. X squared minus 4x minus 21. I know there's going to be people who do that, and it's wrong. And why is it wrong? You got to make it negative with this negative right here. That has to get multiplied into everything. So negative 1 times all that. Negative x squared plus 4x plus 21. And why is it any better? You might argue it was better back here because I had the x-intercepts. Well, there's one good thing about this. What's that? The y-intercept. Raise your hand if you had that one right. A lot of people who have algebra issues aren't careful, and they're not going to get this right. Be really careful. Okay, next one. X plus 4, you have to stretch it out into two of these. You can't just say x squared plus 4 squared. That doesn't work. X squared plus 16 is wrong. And some people think, oh, this is a really important one. Some people think, oh, that's factored form, isn't it? No. You can't have a number out here if there's factored form. That's not factored form. It's not wrong, but it's not factored form. From here, it was a good start, and now I can multiply this times this, and this times this, and this times that, and this times that. There we go. And I get x squared plus 8x plus 16, and then minus 8. X squared plus 8x minus, plus 8. There it is. You could argue this was better because I had the vertex. But maybe you wanted the y-intercept. What was the vertex on this one? -4, -8. Okay, and then last but not least, this one. I'm going to have a random person walking through this. Row 1, person 3, and that would be today, Alexis. What's first? I agree. X minus 1 and x minus 1 have to get multiplied out. And then I'll times it by 3. And then I will add 5. Okay, so this is x squared minus 2x plus 1. And then I can times it by the 3. And then I can add the 5. Could you take over from there?
Then you distribute the 3 to all of them, so it's 3x squared minus 6x plus 3.
And then I add the 5. Final answer. Sorry, I did it in my head. Add 5.
3x squared minus 6x plus 8.
Who got that one right? All right. If you just got all 3 of those right, you have a good chance to do well on this test. There's a few more things you have to know. What are the answers? Well, a lot of people can get it factored like this. Well, actually, I should say it this way. Not many of you could even factor this, but if you did get it factored this far, you'd be really close to having the answers. I'm going to do some easy ones first. This one, the answer would be 5. Why? Because if I put in a 5, it makes it equal 0. See how the answer would equal 0? Think about that. If I put in 2, then the answer would be 0. These are called the x-intercepts, and they're the answers. They're what make the equation 0, 5 and 2. That was pretty easy. What's this answer? Z equals 7. What's this answer? -2. Those are the 2 numbers that give you your answers, and these are the x-intercepts. But what about these? Everybody write this. 2x minus 1 equals 0. That will be one of the top 10 easiest equations you've ever solved. You just got to set it equal to 0 and solve a basic little equation. Okay, now there was a hand up, and I can answer it now while people are working on that.
Can you answer the last question?
On the previous page,
Yeah.
I'll pause the video and see if I can do that. Okay, so I hope you had 2x equals 1, x equals 1 over 2, or 1/2. Raise your hand if you had that one right. Excellent. Well, then what's the equation for this one? JP, this has to be set equal to what?
0.
So tell me the steps. What's next?
You just do subtract 4
Yep, keep going.
and then divide by 3.
X equals -4 over 3. What is that? That'll make the equation 0. That's an x-intercept. Remember the x-intercepts are what make y equal to 0? This is where y would be. See, y is 0. So the x equations make y equal 0. The x-intercepts make y equal to 0. So these are the things that make y equal 0. Those are the x-intercepts on the graph. Okay, good enough. And these, of course, they're just more complicated numbers. You would set it equal to 0, and you'd set that equal to 0, and you'd solve them. Moving on. Okay, the vertex, this one ought to be like, in fact, I'm going to see if you can do it in 15 seconds. Axis of symmetry and the vertex. If that isn't super easy, you're not doing it right. First, do the vertex. Taylor, what's a vertex?
Is it -4 and -2?
Good, and which part of that is the axis of symmetry?
-4.
Yep, and there's your answers. That's how fast that goes. But this, a lot harder. How do you get the vertex for that? The only formula you have to memorize. Bongard, you got this one?
-b/2a.
Perfect. That's the beginning and the end of the quadratic formula. Everybody do that. Careful with the negative on the a here. And see what you get for the axis of symmetry. And then you'll have half the vertex. I'm going to pause. We give that a try. Okay, so a is -1. B is 6. C is -10. And we're supposed to do -b over 2a. -b over 2a. You should have known that that was -6 over 2 times, what's a, Corey? Close. -1. And then I have -6 over -2, which the negatives cancel. 6 over 2 is 3. Raise your hand if you had 3. Okay, awesome. That's a good start. Why am I not done? Because x equals 3 is the axis of symmetry. But, ooh, I heard somebody say it. You're going to do f of 3. 3 and then f of 3. That's not like I'm done, but at least I know I'm supposed to stick it in the function. This will be the one that separates the a's from the b's. And you have to decide, how much do I want an a? Because if you're really serious about this, this is the moment to dig in. You got to stick the 3 in here very carefully. And if you are really careful about it, you'll put parentheses around the x's. And then you'll put a 3 in here and here. And then you'll be very careful about this, 9, and then there's a negative here. Makes it -9 plus 18 minus 10. I personally put these together first. Together they make -19, just a little bit bigger than the 18, which makes -1. Raise your hand if you had -1. All right. What is that again? It's the vertex. I've compared it to the principal at the school. It's involved in almost everything. It's really important. It tells us the range. It tells us the increasing and decreasing. It tells us the axis of symmetry. So many different things. So the vertex is a big deal. All right, we're almost done. Let's see if you've forgotten how to graph. I hope you remembered that an XY chart is your best friend in graphing. If you didn't put one of those on your paper, you need to learn that. Whenever you graph, you just have to make an XY chart. That's why it's on the basic 20 and the top 20. It's really, really important. You got to be able to find points. So I'm just going to keep my life simpler so I don't have to like check every single number in the world. I'm going to say let's put in 3 and 4. And a lot of kids usually choose 1. Let's put in 1, 3, and 4 and see what you get. Yes, you may. Okay, Sage. Did you put in 3?
What?
Did you put in 3?
Yep.
And what'd you get?
It would be, well, you'd put like the 3 minus 3 and then 3 minus 2.
Okay, but 3 minus 3 is just 0. So you could do that and it'd be 0 times 0, but it's still 0.
Okay.
And then what?
So then it's just -1.
Yes. Okay. JP, you put in 4. What'd you get? 4 minus 3 is 1 squared is 1. 1 minus 1? 0. He's right. All right. Ariana, put in 1. Tell me what you get.
I got a 3.
1 minus 3 is -2 squared. 2 squared is 4. And even if it's -2, it's still 4. 4 minus 1 is 3. She's right. Is 3 points enough? Nah, you probably have to do 4 or 5. But once you get the idea, it's not that hard. Shouldn't this be a parabola? Yeah. And if you were extra smart, you could have just said, I know the vertex. It's -3. No, wait, +3, comma 1. I know we got that from sticking in a 3, but do you get I could have got it from this and this? That's vertex form. So you could have just known right away. Ah, I could just start here and make my parabola go over and up from there.
Would it be -1?
Uh-oh. Dang it. Thank you. I should have shifted that down to -1 and then it'll be right. Okay, so just what I'm trying to get across here is it would be a lot faster to make your parabola this way, but most of you probably can't think through where those points are super fast. So you just stick in the numbers. You know, stick in 2, then 2 goes in here and figure out what you get. 2 minus 3 is -1, squared is 1, minus 1 is 0 again. Oh, 2, 0? Yep, look at that. 2, 0. Okay. You have made it, except I'm going to give you 2 last, can you do this? If I said multiply this out, I know you'd have no problem multiplying this out, but that's not what I'm going to say. I'm going to say, what are the x-intercepts? Still pretty easy. Eddie, do you know the x-intercepts?
And then -6, -1?
Yep. Can't trust the stuff on the inside, so...
I was just thinking because the negative has to get distributed, right?
But once I make this 0, doesn't matter if there's another negative. The whole point of the x-intercepts is to make y equal to 0. So do you get, if I make this part be 0, I don't care if there's a negative in front or not?
Yeah.
If that part's 0, I win. So that and that are my x-intercepts. Okay, but what if it isn't x-intercepts? What if they asked for the vertex? Yuck. Why yuck? Because it's not vertex form. Some of you wouldn't even know how to get vertex form if I gave you the vertex. But they haven't given me the vertex, and they want vertex form. What the heck? My best advice to you is just always start by multiplying them out. So everybody start by multiplying the red thing out. Wait. I shouldn't do 6x. Before I multiply that negative out, I should put these two guys together. And that'll make 7x. Then I can make it negative. So it'll be negative 7x minus 6. Cool. I still don't see the vertex. But why am I closer? All right, do you know?
Because you can factor.
If I wanted it factored, I'd use this. That tells me the x-intercepts, still not the vertex. I'm trying to find the vertex here. You know what to do?
Negative b over 2a.
Yes. X equals negative b over 2a. So, negative b. McCormick,
Would be negative 7.
why did I just do it wrong?
Positive 7.
Why positive 7?
Because it gets rid of, because there's 2 negatives.
There's two negatives. Negative, negative 7 is really what it is. So, anyway, bottom line, I should use opposite of this number. So, positive 7 over 2a. 2 times what's a?
-1.
So, final answer 7 over negative 2. That's kind of gross. But that would have been the axis of symmetry. Now, that would be pretty brutal if we gave you one that hard. Because now you'd have to go 7 over negative 2, which is, by the way, negative 3.5, has to go into the function. Do you get what I mean? You'd have to put one here, and you'd have to put one there, and you'd have to multiply it all out, and it'd be really gross. So don't worry, it probably won't be that bad. Yes?
Are there calculators allowed on the test?
Let me think. I think we're going to be allowing calculators on the test. So yeah, if you bring your calculator, you can't use your iPad. Too easy to cheat.
No.
All right, so yeah, if you had a calculator, 3.5 wouldn't be that hard to put in. But you'd have to put parentheses in. I'd have a negative and then parentheses, negative 3.5 squared minus 7 times negative 3.5 minus 6. With a calculator, I think you guys could do that. That's how you figure out what to put here. All right, so one last time. I'm afraid about this one. If they say standard form, you multiply it out. If they say what are the x-intercepts, do you know what the x-intercepts are? Yeah, they're easy. What are they?
Negative 6,
Negative
negative 8.
8, negative 8. Negative 8 and negative 6. Okay, and what if they say I want the vertex? You got to multiply it out. And then use the formula, which is what? All right, I think you're ready. So I want to warn you that the Schoology quiz for today is more important than usual. I'll be looking extra close to see that you did it. Okay, because this is your last chance to review for the test. It counts as homework, which means it counts in your grade. And it's the best thing you can do to get ready for the test tomorrow. Do you see why it's really way important, more than normal? Okay, would you please start it? All I can ask in class is that you open it. So find the Schoology quiz for today and open it.